Okay, now if you've watched the first video I did, I treated solving for the sum of a quadratic equation and the product of a quadratic equation, the product of the roots of the quadratic equation, where we did alpha plus beta and we got our answer as what? 4 over 3. And then we did alpha beta, which is the product of a product of the roots of a quadratic equation, and we got what? Minus 1 over 3. So we'll move on further to solve for the C, D, and E parts. Now you can see it here. The first one is alpha square plus beta square. So let's do that. We have alpha square plus beta square. Now, to solve this question, remember the only thing we can work with is only alpha plus beta and alpha beta, seeing that that's the only one that we have a formula for, which is what? Alpha plus beta is minus b over a, and alpha beta is minus 1 over 3. But for alpha square plus beta square, there is really no formula or direct formula to it, but we can invent this formula. We can invent the formula from an initial expression. Now that expression can help us invent the formula for solving alpha square plus beta square, because one thing you must know is that everything you're solving must be in the form of what? Alpha plus beta or alpha beta. And when I say that or, the or means it can be the both of them appearing at the same time, or it can be either of them appearing one at a time in a particular solving. Okay, so let's look at this one, alpha square plus beta square. Now permit me to wipe this off. Alpha square plus beta square. As I told you, we have to get the formula from another formula you're already aware of, and that's the expansion formula for raised power 2. So let's look at this. When we have alpha plus, when we have alpha plus beta, and it is bracket raised power 2, when you open it, what is going to give you? It will give you what? Alpha square plus 2 alpha beta, right? Plus beta square. Okay, now this is the expansion of this particular expression, and if you notice something, we can see alpha square and beta square inside the expansion. So to make alpha square plus beta square the subject of our equation, I will take my plus 2 alpha beta over to the other side, and it will become minus 2 alpha beta. So that will give us what? Alpha plus beta raised power 2 minus 2 alpha beta. When plus 2 alpha beta crosses over to the other side of the equation, then we have here as what? Alpha square plus beta square. Now that is to say that we've gotten the way of interpreting alpha square plus beta square as what? Alpha plus beta raised power 2 and minus 2 alpha beta. And notice something, our equation, our new equation, is now in the form of what? Sum of roots of a quadratic equation and what? Product of roots of a quadratic equation. And this is where we're driving at. Therefore, when I'm to solve for alpha square plus beta square, alpha square, okay, I think I should use a different color, alpha square plus beta square, I will rather use the solving for what? Alpha plus beta, close the bracket, to the power 2 minus 2 alpha beta. Now this will just be a substitution solving, because we've already found the value of alpha plus beta and we've already found the value of alpha beta. So what's the value for alpha plus beta? From our solving, we got it as what? 4 over 3. So that will be what? 4 over 3 raised to the power of what? 2 minus 2 times, what is alpha beta? Alpha beta is minus 1 over 3. So that's minus 1 over 3. Then when we open the brackets with the raised power 2 to give us what? 4 square, which is 16, over 3 square, which is 9, minus, now minus times minus will make this plus, so this is actually plus. 2 times 1 is 2, and then we have 2 over 3. So we can solve this using LCM of the denominators, and then we solve for their numerators. Okay, so using LCM, we have this as LCM of 9 and 3. Okay, LCM of 9 and 3 is going to give us 9. Then 9 in 9 is 1, and then here's 16 plus 9 and 9, 3 into 9 is 3, 3 times 2 is 6, and then 16 plus 6 we have 22 over 9, and I don't think anything can divide this again. Okay, so this is the value for what? Alpha square plus beta square. Okay, so come back to the next video, and then we'll solve for 1 over alpha plus 1 over beta and the other parts.